בעיה שלכם. ערב טוב, תודה שבאתם, ברוכים הבאים לאירועי שבוע החלל במכון דוידסון בפיתוח מדעי, וברוכים הבאים גם למי שמצטרפים אלינו בזום. היום אנחנו בשידור חי אינטרגלקטי לכל מיני מקומות שרואים אותנו בעולם. ערב טוב לניצן שמנהל את ההפקה שלנו בזום, וערב טוב לאוהד שמתרגם את השיחה שתהיה פה בהמשך בעברית, ויהיה אפשר לקרוא את התמלול על המסך שבצד ימין. אז אנחנו תכף נצא לסיור וירטואלי בחללית אוריון, החללית שאולי תביא בני אדם לירח בעוד כמה שנים, ואולי גם תפרוץ את דרכה של האנושות למקומות אפילו יותר רחוקים ולא פחות מאתגרים. ולפני שאנחנו נצא לסיור הזה עם האסטרונאוט מורין מנאסא, נמצא איתנו פה בר חיון, מנהל התוכן של סוכנות החלל הישראלית, ויוצר הפודקאסט סוכן חלל שמאוד שווה להאזין לו. אתה נמצא אותו גם בכאן הסקטים, נכון?
כן, כאן הסקטים.
אז כדאי לזכור ולשמור. אז בר, לפני שאנחנו מתחברים לחלל עצמו, בוא ניתן קצת רקע, הקשר יותר רחב לאוריון. למה בכלל נאסא רוצה לחזור עכשיו לירח?
אוקיי, אז יש איזה כמה תשובות. התשובה בדרך כלל שנותנים למורים, לתלמידים, ראיינתי את ריד וייזמן לפני כמה ימים, והוא אמר שהתשובה היא פשוטה, סקרנות. אנחנו כמין האנושי, אנחנו מסקרן אותנו לפרוץ גבולות. למה מטפסים על ההר? כי הוא שם, וזאת הסיבה. באופן עמוק יותר יש עוד סיבות, וכמובן הירח משמש, נתפס כקרש קפיצה למאדים. קודם כל, אם אנחנו מתכננים בכלל לשלוח אסטרונאוטים עשרות מיליוני קילומטרים למאדים, אנחנו קודם רוצים לבסס איזשהו הוכחת היתכנות, לראות שזה בכלל אפשרי לעשות את זה בגרם השמיים הכי קרוב אליהם, במרחק 400,000 קילומטר, וזה הירח. הירח הוא גם קצת יותר מאחוז במסה שלו, בערך אחוז מהמסה שלו מכדור הארץ, ולכן כוח המשיכה שלו הרבה יותר נמוך, לכן יהיה הרבה יותר קל לשגר משם משימות לחלל העמוק ולמאדים. בירח יש מים, גם במאדים יש מים, קרח מים, לא מים זורמים כמובן, אבל מהקרח הזה אפשר לפרק אותו, ממה מים עשויים? מחמצן ומימן. אז אפשר את החמצן לנשום ואת המימן להפוך לדלק רקטי. אבל שאלת מיליארד דולר, אני חושב, היא הרבה מיליארדי דולר, זה למה זה קורה עכשיו. כי נאסא והממשל האמריקאי מדברים על זה כבר כמה עשרות שנים, וג'סיקה מאיר, האסטרונאוטית ג'סיקה מאיר, אתמול בכנס היא אמרה שתוכנית אפולו בשיאה, היא עלתה, התקציב של נאסא היה 4% מהתקציב הלאומי הכולל של כל ארצות הברית, וכיום פחות מחצי אחוז, ולאף אחד אין ספק שכל להקים מושבה על הירח יעלה יותר מתוכנית אפולו. אז איך עושים את זה? אז נאסא סומכת גם על שותפויות עם מדינות ששותפות בארטמיס, ישראל ביניהן, וגם, אולי בעיקר, על שינויים בתעשיות החלל בעולם בכלל, בארצות הברית. וזה קורה...
כניסה של גורמים פרטיים.
כן, כניסה של גורמים פרטיים.
אוקיי. אגב, מי שרוצה לשמוע עוד על התיישבות על הירח, מוזמן לבוא אחר כך תשב על ההרצאה בנושא הזה. עכשיו, החללית אוריון שאנחנו נראה היום, היא תיקח בני אדם לירח, אבל היא בעצם לא תנחת על הירח, נכון? איך זה בדיוק יעבור?
אז החללית אוריון בארטמיס 2, כמו באפולו 10, היא תעשה סיבוב מסביב לירח ותחזור חזרה. היא כן תגיע רחוק יותר מכל חללית מאוישת אחרת, כמעט 9,000 קילומטר מעל פני הקרקע של הירח, אבל כן, היא לא תנחת על הירח. גם בארטמיס 3, שזאת משימה שבה ינחיתו אסטרונאוטים על פני הירח, היא לא תנחת על הירח, היא תחבור לחללית הסטארשיפ של ספייסקס, והיא זו שתנחית שני אסטרונאוטים על הירח, ובהמשך היא גם תתחבר לתחנת החלל הירחית, ואולי עוד חלליות.
זאת אומרת, רכב נחיתה בעצם יחכה לאסטרונאוטים כבר במסלול סביב הירח, אוריון תתחבר אליו, הם יעברו לשם, ירדו אל פני השטח של הירח, ואחר כך ימריאו, יחזרו לאוריון ויחזרו הביתה.
כן, כן.
טוב, ומתי כל זה קורה?
אז קודם כל זה כבר קרה, התחיל לקרות, יש לנו, הייתה משימה בנובמבר 22 שאוריון במסגרת משימת ארתמיס 1 כבר עשה את הסיבוב הזה מסביב לירח, היא פשוט לא הייתה מאוישת החללית, זאת הייתה מין חזרה גנרלית כזאת, הייתה מאוישת בשתי בובות, זוהר והלגה, אבל לא באסטרונאוטים. וזאת הייתה משימה שבעצם נועדה לבחון את השיגור של המשגר הגדול בהיסטוריה, ה-SLS של נאס"א. זו הייתה משימה שנועדה לבדוק את המערכות של החללית אוריון, שעוד מעט אנחנו נראה את מורין מדבר עליה, וכמובן את השלב אולי הקריטי ביותר, החזרה לכדור הארץ, חזרה לאטמוספירה. ואז בשלב הבא יש את ארתמיס 2,
מתי זה קורה?
זה קורה, זה מתוכנן לקרות בספטמבר שנה הבאה, ספטמבר 25, שזה יהיה בדיוק אותו דבר כמו מה שאמרתי עכשיו עם ארתמיס 1, רק מאויש ב4 אסטרונאוטים, והשלב הבא, ארתמיס 3, זה בספטמבר 26 למעשה.
אם לא יהיו דחיות נוספות.
אם לא יהיו דחיות נוספות, ספר להניח שיהיו.
כן. ואז יהיה כאמור נחיתה על הירח. עכשיו הזכרת את משימת ארתמיס 1 והבובות הלגה וזוהר, זה בעצם ניסוי ישראלי שהיה שם בחללית אוריון.
ניסוי של סוכנות החלל הישראלית בשיתוף עם סוכנות החלל הגרמנית, DLR, שהרי מה קורה מעבר למסלול הקרוב לכדור הארץ, יש קרינה מאוד מאוד חזקה, ואנחנו צריכים למצוא דרכים להגן על האסטרונאוטים שטסים לחלל העמוק. יש חברה ישראלית שהם סטמרד שפיתחה אפוד הגנה מפני קרינה, והוא נוסע בארתמיס 1, ההצלחה, בניסוי זו הייתה הצלחה ממש יפה, ולכן הוא גם יגן על האסטרונאוטים שיטוסו בארתמיס 2, ומה שעשו, שיגרו שתי בובות, כמו הבובות האלה בחלונות ראווה, מכירים את זה? רק שעל הבובות האלה יש הרבה חיישנים, לאחת קוראים זוהר ולשנייה קוראים הלגה. זוהר לבשה את
שמות שנבחרו במשאל ציבורים.
כן, נכון, לגמרי. זוהר לבשה את החליפה של סטמרד, והלגה לא לבשה, על מנת לבחון את ההשפעות של הקרינה אחר כך עם חזרתן לכדור הארץ.
והתוצאות?
התוצאות חיוביות מאוד, ראו שבעצם למעשה מה שאנחנו הכי חוששים ממנו זה התפרצויות שמש. אז הקרינה מאוד מאוד מסוכנת, ולא תמיד יש התפרצויות שמש. אז מה שזוהר והלגה עשו עם חללית אוריון, הם טסו באזור שנקרא הקרובות במנהל, ששם יש המון קרינה, ואחרי שהם חזרו לכדור הארץ במעבדות DLR, שזאת סוכנות החלל הגרמנית, בדקו את כל אחת מהבובות וראו שאכן הבובה זוהר הייתה מוגנת ולא ספקה את הפגיעות של הקרינה.
אוקיי. איזה עוד ניסויים או דברים בדקו באוריון במשימה הראשונה הזאת? ולמה בעצם לוקח כל כך הרבה זמן מאותה טיסה לא מאוישת עד שמתחילים להטיס בני אדם?
אז יש הרבה מערכות שבודקים. יש את מגיני החום של אוריון, שצריך לראות שהם עובדים כמו שצריך, מה שציינתי קודם, שבחזרה לאטמוספירה. כל המערכות אגב אוטומטיות לגמרי, זאת אומרת זה לא שהאסטרונאוטים באמת מטיסים את החללית הזאת שתכף תראו, אבל כן צריך לראות שגם המערכות האוטומטיות האלה עובדות כמו שצריך. צריך לראות שהמסלול סביב הירח הוא תקין. מה עוד? אתה תוסיף.
שהחללית יכולה להניע את עצמה, להפעיל את המנועים ולכבות אותם כשצריך. מערכות תמיכת החיים, יש חמצן בחללית שהלחץ לא יורד לרמה מסוכנת. כל הדברים האלה, וגם יש שם כל מיני פיצ'רים מאוד נחמדים באוריון, מערכת שהיא דומה קצת לסירי או לאלקסה, שמדברת עם האסטרונאוטים ושומעת את הפקודות שלהם ובוחרת להם לאיזה תחנות רדיו להאזין בדרך, אבל גם אחראית כמובן על התפעול של מערכות החללית. אבל באמת השאלה למה לוקח עכשיו כל כך הרבה זמן להכשיר את החללית הזאת בטיסה מאוישת?
אני חושב שזה פשוט, אתה שואל בעצם, כבר עשינו את זה פעם בשנות ה-60 וה-70, אז מה כאילו הבעיה?
לא, עכשיו, עשית כבר טיסה לא מאוישת בשנה שעברה, יותר משנה כבר, ואז יש עוד 3 שנים עד שמכשירים את אותה חללית בדיוק לטיסה עם בני אדם.
אז אני לא יודע בדיוק, אני יודע שהטיסה, המשימה הזאת של ארטמיס 1 היא לא הייתה מושלמת, גם עד שסוף סוף שיגרו את ה-SLS היו מלא תקלות כל פעם עוד ועוד דחיות, וגם רוצים לטייב את כל המשימה הזאת.
כן, מילת המפתח כמובן שאתה מדבר על טיסות עם בני אדם היא בטיחות, שאנחנו לא יכולים, לא אנחנו, נאס"א לא יכולים להתפשר על שום דבר שקשור בבטיחות האסטרונאוטים, לכל מערכת שם יש פלן B ופלן C וגיבויים על גיבויים, ואת כולם צריך לבדוק שהם עובדים כמו שצריך, וגם יש עוד נקודה פעוטה שאנחנו מחכים לה, זאת אורכת נחיתה שקצת מתעכב אצל ספייסקס,
כן.
הסטארשיפ שעוד לא ממש עבר את המבחנים הראשונים בהצלחה.
כן, עוד לא ממש ימרית.
כן, והוא ישמש רכב הנחיתה לירח של החללית אולי. עוד משהו שאנחנו צריכים לזכור לפני שאנחנו מצטרפים לחללית עצמה?
לא שם.
אוקיי. אז שאלה?
שתי שאלות.
מהר, כי אנחנו נראה לי משתפים.
על החלל. יש משהו שמתואר כרגע על החלל או משהו?
יש מה?
משהו שקשור לחלל כרגע?
יש כל הזמן פעילות בחלל.
לא, למשל בבית הספר שלי מלמדים על החלל.
לא הבנתי כל כך את השאלה. תשאל אותנו אחר כך, בסדר? למה היום?
הבנתי.
אוקיי. אז נקודה טובה. היום למעשה בדיוק לפני 21 שנים התרסקה מעבורת החלל קולומביה בדרך חזרה מהחלל לכדור הארץ. בדיוק, נהרגו כל 7 אנשי הצוות באסון הזה, כולל האסטרונאוט הישראלי הראשון, אילן רמון, ולמעשה זאת הסיבה שמציינים את שבוע החלל הישראלי בסוף ינואר. במקרה לגמרי זה גם סמוך לשני אסטרונאוט אחרים שהיו לתוכנית החלל האמריקאית, גם אסון צ'אלנג'ר ב-86 וגם אסון אפולו 1 ב-67, כולם היו ממש באותו שבוע ובשנים אחרות. רק שנייה, לפני שאנחנו מתחברים ליוסטון לשיחה עם האסטרונאוט מורין, אז קודם כל נספר טיפה עליו. מורין הוא רופא, דוקטור למיקרוביולוגיה שעבד הרבה שנים בנאס"א, הוא טס פעם אחת לחלל בשנת 2002, הוא עבד בנאס"א כרופא תעופתי, לפני זה הוא עבד כרופא צוללות בצי האמריקאי, אחר כך עבר להיות רופא תעופתי ואז התקבל לנאס"א כאסטרונאוט, טס במעבורת החלל אטלנטיס, עשה כמה וכמה הליכות חלל, כלומר יציאה בחליפה מחוץ לחללית, אחר כך הוא עבר למשרד החוץ האמריקאי, התפקיד הזה אנחנו נדבר איתו ממש עוד מעט. בסוף השיחה עם מורין יהיה זמן לשאלות, גם פה מהקהל וגם האנשים שנמצאים בזום, ניצן ינהל את הצ'אט הזה, אז מי שיש לו שאלות בזום מוזמן לכתוב לנו בצ'אט, וניצן יבחר השאלות ככל שיותיר לנו הזמן. האם אנחנו כבר יכולים להתחבר ליוסטון?
רגע, יש לי...
עוד שנייה אנחנו נתחבר. Hello. Good morning.
Hello, can you hear me?
Oh, we're very happy to see you.
Great.
Thank you for
Well, it's an
joining.
honor to be here today
Thank you very
to talk to you.
Here at the Davidson Institute in Rehovot, Israel, and we're looking forward for a tour in your Orion station. Please take us.
Well, it's a great honor to be here, and I'm very honored to be able to talk to you guys in Israel and give you an orientation to the Orion spacecraft. And ironically, I gave astronaut Ilan Ramon his very first lesson, him and his partner, Zach Mayo, their very first class at the Johnson Space Center, which was an orientation to the shuttle avionics. And so I'm glad to be able to give you guys an orientation to our new ship, the Orion's avionics. The Orion has already flown several missions unmanned as test flights. There will be a flight coming up in September of 2025. We'll take a crew that is already in training and already been identified and take them around the moon in a mission similar to Apollo 8, which will be a test mission to shake down the new spacecraft. This is the cockpit of Orion. It has two windows overhead, and there's some other windows as well, but these are the prime windows for the crew. The crew is seated in front of these three screens. They're called display units, and DU1, DU2, DU3 for display unit 1, 2, and 3. There is a, over here in front of DU1, that's where the commander would be. So the commander would be on his back, sitting here, looking up at this DU1. The pilot would be about a little less than a meter away from nose to nose in front of DU3, and both of them would share DU2 in the middle. We're going to come back and talk about what's on the computer screens, but before I do that, I want to tell you about the other physical hardware switches and hand controllers. So there are 7 panels on Orion that are labeled from F1, 2, 3, 4, 5, 6, and 7. And that is the entire switch complement for Orion. Aside from some cranks to open the hatch, this is the cockpit. Unlike the shuttle that had 100 panels and sheets of circuit breakers, or if you've seen, most airplanes will have big rows of switches. All of these switches are here, and most of the switches are virtual switches on computer icons. These switches are primarily used in emergency situations if you don't have access to the computer or post-landing, or in very deep contingencies where you need to be able to go directly and operate a switch. In terms of spacecraft, one of the most important things of the spacecraft is handling heat. And the heat in the spacecraft, you need to get rid of it, and you have a fluid system and cold plates on the avionics and heat exchangers for the air conditioning. And then that fluid that is heated by those heat sources then is taken to a radiator where it's pumped overboard. And so that's how the vehicle gets rid of its heat. And so this is and that's called environmental control and life support. That environmental control, this is the panel for that. And so that has switches for the pumps and the loops, as well as when the crew is in their spacesuit, they have a cooling garment, which would be like a small tubing woven into underwear, and cold water is passed through that tubing to get rid of the crew's heat and keep the crew cool. And so there's a pump here for the liquid cooling garment that the commander can control. So that's the life support switches. The next row of switches is for the computers. Key thing when you're in space is you need to keep track of where you are. That's called the state vector. And that state vector needs to be continuously updated or propagated, and measurements are taken to refine it continuously. But if you lose that state vector, you're in big trouble, and you're going to need to get it back, or you're not going to be able to come home. So you actually have 9 computers, and you have 5 switches here that control the first 8. And the way it works is this. Those are arranged in 4 groups called flight control modules. And a single flight control module can control this entire spacecraft. But if one of these flight control modules fails, it'll automatically switch to the next one. So these are all switches for the first 4 flight control modules. And then there's a backup flight control module called the BFS, or backup flight software. And that's if the other 4 have all failed, it would switch over to that backup system. And the backup system is built with a different design team, a different piece of computer chip, different silicon, different compilers, totally different programs written by different people, so that a systematic mistake that could affect these 4 wouldn't also affect the design of this last chance computer. Coming to the panel F3, you have 3 switches up here which are used to control the panel lighting and also the lighting in the cabin. And then you have 2 switches here that are under these protective covers that will close with a spring. And there's a button under here. Those are for the digital autopilot. Those are emergency buttons, and they would allow you to go to free drift, which would mean the digital autopilot would stop trying to move the or control the spacecraft, or it could go to inertial, in which case it would lock the spacecraft's position in space or its attitude so that it wouldn't continue to tumble. The next button here we have is a warning silencing button to bring the crew's attention to a problem or a malfunction. There are sounds on board that will fire, that will sound a siren for a fire and other tones for other emergencies. Once that's done its job of bringing the crew's attention to the cockpit, we'll push this. And we will have a chance to hear one of those tones, and I'll tell you when that's going to happen, but it won't be for a while. Next, you have a series of switches here that are for purposes of an emergency landing. And these are only used if you lose your computers. And so this is a pretty deep contingency, but as a last chance, if you are already on a trajectory headed towards the Earth and all of your computers should fail, the crew is still able to get safely to the ground using these switches. And the way that works is you can see these switches with the checkered backgrounds. That means that those are very hazardous. So it means stay away from them unless you really know what you're doing. But in that emergency, the very trained crew would turn on these 3 switches to activate the rest of the switches. And then they're already heading towards an entry point on the Earth. They would activate the propellant for the crew module. They would then separate the crew module from the service module. So the module would move away from the vehicle. They would then use these switches to fly the vehicle and change its position in space, looking out the window at a reference to get in the right orientation to re-enter. They would look over here and see an altitude on it with an altimeter once they're in the atmosphere. Once they get to 26,000 feet or about 24,000 feet, they would deploy the first set of parachutes that would slow them down. And then once they get to about 1 mile or 6,000 feet, I guess to be about 2,000 meters, they would deploy the main chutes, and those would go out and that would slow down the vehicle, and then you would land and hit the water. And then once you're in the water, you would cut the parachutes away because you don't want those parachutes to drag you. And then you have some bags that inflate on the front of the capsule so that if it's upside down in the water, these bags are down here at the bottom, and they would flip the capsule upright so that the crew is not upside down hanging in the capsule. So that's basically the process of re-entry on Orion and how you would do it with these emergency switches. Next, we have a panel here. These are for various connections between the batteries and the buses. By bus, I mean a big connection of cables that connects different parts and moves electricity between different parts of the spacecraft. So those connections are called buses, and this is where you control them. In addition to being an altimeter, this dial also shows you critical voltages for the batteries and for buses. Next, we come over here. These switches would all be used post-landing. I mentioned that you have over in the ecosystem, we had the crew's cooling for their suit, for their liquid cooling garment. But once you're in the water and once you've returned to the atmosphere, that radiator is not going to be there anymore. It's in fact part of the spacecraft you've left behind. So you still need to get rid of heat. And so what they do is they boil ammonia. And by having the ammonia evaporate, that provides cooling to the coolant loops and then to the liquid cooling garments. So the crew stays cool and all the electronics stay cool as well when you're in the water. After a couple of hours, that runs out. And then you need to get out of your suits and you need to turn on the snorkel fan. So this snorkel fan, you can see it has a hazardous border. If you open these switches, a valve opens between the cabin and space that a tennis ball could go through. So you definitely don't want to do that in space. And so in addition, as a reminder and protection, there's another cover that clips over these switches to make absolutely certain you don't do them at the wrong time. Then we have a SAR radio beacon. The Orion capsule, as it enters the atmosphere, has radios that transmit on emergency, international standard emergency frequencies, a beep beep beacon. Once you get in the water, you want to turn off the beacon so that you can talk on your walkie-talkie to the SAR forces, and they can coordinate with you, them coming in to pick you up and rescue you. So you want to be able to turn off the beeper, the beacon with this switch. And then you have some strobe light switches. These are navigational lights like every ship has or every airplane has. So when you're in the water, you turn on those strobe lights so that if you were in sea, a ship could see you were there and hopefully not run you over. Finally, you have another panel here, which is more electrical panels for the electrical control panels. And then there's a switch here for the emergency comm. Normally we use an S-band comm, a very sophisticated system that has phased array antennas that track where the antenna is on the Earth and where the spacecraft is. But if you lose those sophisticated systems, you still have an emergency S-band, but it's totally manual. There's a switch here at the bottom. The crew has to manually pick which antenna they want to use to point to the ground station. And as the vehicle moves around the Earth, that could change. And so they're going to need to constantly be adjusting the antenna so that they can keep talking to the ground. So that's basically an overview of the switches. Next, I want to talk about the hand controllers. There is here you see mounted on both sides of the cockpit, a translational hand controller. But what this does, it has a little cube in the middle, and the direction you move the cube is the way the spacecraft will move in space. So when you push this in a direction, it'll fire jets on the outside of the spacecraft, and the whole spacecraft will move, translate in a straight line in that direction. So you can go up, down, left, right, and in and out. So that's how you actually maneuver the spacecraft to dock to another spaceship. Next, we have a rotational hand controller. There are two of these. The commander and pilot each have one. This is similar to the stick on an airplane. And so this is held down near your knee. And by tipping it back and forth, twisting it left and right, or tilting it from side to side, you are making a roll, pitch, and yaw inputs to control where the spacecraft is pointing. So if you are flying the Orion in to land it, and you're choosing to fly it manually, this is how you would fly it. Or if you were in space and you wanted to, for example, point the solar rays of the spaceship at the sun, you could adjust the position or the orientation of the spaceship with the RHC, a rotational hand controller, RHC. So that's the second hand controller. The third hand controller that we have is called the CCD, a cursor control device. This is something unique. It's sort of like a mouse, and it's held in your left hand and it's down by your knee on the side of your chair. And this is when you are on ascent and entry and you're underneath a lot of G-forces, you don't want to be reaching your hands up here because your hand could be thrown around, hit your partner, hit something. And so you want to work in what we call reach zone 1, where your hands are right by your side. And by manipulating the buttons on this hand controller, you can basically do the same things that you can do by reaching up and touching these buttons around the bezel. So those are the 3 hand controllers. So with that, I want to go on and talk about the computer screens. And the computer screens are where most of the action is on Orion. And so we're going to come here into DU2. And we'll go ahead and put the primary flight display. This has instruments similar to what you'd see on an airplane. There's an attitude indicator, an ADI ball. There's a horizontal situation indicator, basically kind of a fancy compass. You have a velocity or speed indicator. And right now you'll see, I don't know if you can see the number, but it's at 1.34. And what that's telling you is we haven't launched yet in this model, and that's the speed of the rotation of the Earth. Is you're going at about 1,000 feet per second. So that's about 1.3 times the speed of sound right now, just from the rotation of the Earth. And then you have your altitude. And then there's some gauges here that tell you about information about your engines. And then there is what's called a traj plot, that is a plot of your altitude versus your speed. And there's a line there that is planned for your trajectory. And then there are different other markings on that as you go through different milestones of the launch. So we'll go ahead and lift off. So there we have liftoff. You can see the engines have lit. And now we see our indicator here of the vehicle is coming up. You have a predictors, and right now we're going straight up. And then we're going to do a roll program. So we align the vehicle with the trajectory that we want to go into space on. So this is the roll program. And meanwhile, the vehicle's starting to pitch over. You can see that it's doing a pitch maneuver and a roll maneuver. And this is the icon that represents Orion, and these are predictors of where the computers think it's going to be in a minute and 40 and 20 seconds. And so you want to see these predictors and the vehicle going up this track, and that indicates that you're going where you want to go in space. So this is what the crew would be monitoring during an ascent. Of course, the G-forces would be on their body, and there'd be lots of more noise and rumbling, but that's basically what the crew is following. And if all goes well, they would just ride that out. In the event you had an emergency, they would come back on the RHC, and the RHC on the side has a door that you open with a karate chop, and it exposes this button. And then they would push this button, and remember this is down by your knee, they'd push that button and that would abort the mission. Okay, so next thing we want to do is just talk about malfunctions. So if something goes wrong, the computers are monitoring it, and they would give you a notification. We might hear a tone for this, so don't be startled, but we will have a malfunction will occur. So we can hear that tone. So the first thing we want to do is silence it. And so I push that button, and that silences the tone. And I want to go now to look at what that is on my fault display. And there I can see the message. We're having a problem with one of our batteries, is having an overtemp problem. And that's now showing you that. It shows you both on the center status bar, which is here in the middle, that's always visible. But if you had a whole list of them, you'd see them on this caution warning display. And these messages are also prioritized for the crew. But once you have the message, now what are you going to do about it? Well, for a vehicle as complicated as the Orion, you need to operate from procedures. So we have a built-in procedure system called EPROC, or electronic procedures. And so this button says open EPROC. And so I push that. And now that takes me from that message right to the procedure that I need to work. So I'm going to walk through this procedure with you. Before I do the procedure, though, I just want to show you how the commanding works on Orion. So just setting aside our procedure for a second. This is another procedure for the propulsion system. And you can see, if you look closely, you'll see there's a little cursor that moves around between these valve icons. And so that's, if I wanted to work with that cursor, I would push the enter button and I get a little pop-up. And then I could come down here and select a command and send it. And then I could come in here and select another command. Now say if I wanted to close it, that closed it. And now say, I want to reopen it. I would reopen it. And then I can bring it back and we'll let the vehicle command it automatically. So that's how the crew commands Orion. They go to an object they want to command. They open a pop-up. From within the pop-up menu, they select the item they want to transmit. They transmit that command, and then that takes the action. That's how the crew controls Orion for the most part, is through those pop-ups. So let's come back to our procedure and we'll see how that happens with the procedure. You can see we went on and did something else. So the procedure went into a standby mode and it turned green, and you can see it has the button resume proc. So we're ready to go back to our our procedure now. So I'm going to push the resume button, and you see we come back with this purple color. So that's the color of eProc guiding you through the procedure. The first thing is just looking at the title. It lets you read the title and make sure that's the title you want. I click OK, and now it moves on to the next line. And now it has the display that I want to get to. You saw that we can get to displays by pushing these different buttons to get through the different displays we want to be on. But within the eProc will take me to the display that's needed automatically. So that saves me some time. And next, it highlights this item. You can see it's in red and it has an arrow. There's a problem with this current, and that makes sense with the message we got. And so the first thing it asks you, is this amps value greater than 50? And we can see the number here or here that yes, it is. So I'm going to push the yes button. So we push that. It moves to the next line, and now it's going to be checking battery 2. And you can see the way these buses are arranged. Problem with battery 1, there's redundancy with battery 2. We're going to switch over to battery 2, but before we do that, we need to make sure battery 2 is okay. So we're going to do a couple checks to make sure that we don't make our problem worse. And so we see that the voltage of this battery is within the range it needs to be, so that's okay. We see that this battery percentage charge is good. It's well charged, so that's good. And then we can see that this current is not high already, so those are all good things. And now we see that this battery is on, so it'll be able to take over. And so now I'm ready to, I've done all the checks, qualified this battery. That battery is going to be able to help us. And so now we're going to disconnect this battery that has the problem. So I'm going to send the command. Notice we got a pop-up. The pop-ups are purple with eProc, but we got the pop-up. It's already selected the option, and it's ready to transmit. And so now you can see that went off, and it is now put a box around the current. And it tells you that the amps are 0, and it says make sure that the amps are 0. Okay, it is. And it wants to make sure that this current isn't too high, so that's good. It went up, but it's not over 50. And then we want to make sure that the bus still has a good voltage, and it does. And that we want to verify that that bus isn't drawing too much current. And so with that, we have finished the procedure, and we go back to our table of contents, and we can go back to our flight display. So that basically gives you an idea of how the crew will operate Orion and work emergency procedures. Let's see. I think with that, we might go to questions.
Thank you. We all feel ready to jump into the capsule and start flying. Okay, questions from the audience. You can ask in Hebrew, אתם יכולים לשאול בעברית, ואנחנו נתרגם את השאלות לדוקטור מורין. שאלות? כן, יש פה שאלה?
כמה תקופות ג'יבר מדברים על אסטרונאוטים כאן?
Okay, the question is, during launch, what are the G-forces that the astronauts are feeling?
Yes. Right, the G-forces that the astronauts experience on liftoff, it varies somewhat from vehicle to vehicle. On the shuttle, it had an upper limit of 3G. It started off at about building up to about 1.5 G when the solid rocket boosters came off. And then as the engines then would have the same force, but the vehicle would be lighter and lighter as the fuel was consumed. And so the vehicle would accelerate up to 3 Gs. And then once it got to 3 Gs, which is about 7.5 minutes into the flight, they would reduce the thrust of the engine so that they never exceeded 3 Gs. But so the shuttle on launch, the maximum was 3 Gs.
What about the Orion?
Orion can be a little bit higher.
Okay, thank you. And question from the chat.
Yeah, okay. Hey, thank you, Dr. Mourin. So a few questions from the chat. So a question from Ourian, she's 15-year-old from a girl from Moshav Yechini. What is the one thing that you would like to discover as part of space exploration?
Yeah, so what would be the one thing I'd like to discover as part of space operations? That's a really good question. I think the ability that would be long-term the most important is how to really utilize the materials in space, like the materials on the moon and the asteroids or on Mars, to use those materials to make the things that people need to live and to breathe and to build other spaceships and rocket fuels. That's going to be really the key to sustained presence. So I think the very important thing to discover is how to use materials in space to sustain yourself in space. And I think that is how I'd answer that question. That's a very deep question.
Another question? Okay. So another question we have is, how does NASA plan to deal with the issue of space debris and the potential risks of Kepler effect?
Yeah, so how do we deal with space debris? Space debris is a real challenge, particularly close to the Earth. Some of the things that were done with the shuttle and the space station is, one is designing the ship. What we found with space debris is that if you have a relatively thin piece of metal a little bit distant away from the hull, that can provide a lot of protection, because a fast-moving particle, which might be the size of a grain of sand, would hit that first piece of metal and explode, but it wouldn't break into the hull underneath. And so the space station has these panels that cover it to provide that kind of micrometeorite protection. You also have layers of fabric on the spacesuits that provide some micrometeorite protection in the same way. Another thing you can do is positioning the vehicle. And when the space shuttle was in orbit, they positioned it so that the tail of the vehicle, which was far away from where the crew were, is into the direction the vehicle was traveling, into the velocity vector, so that if you ran into something, it would hit an engine, but it wouldn't destroy or penetrate the cabin. The other thing you can do is you can track debris in space, and there are databases where that's done. You track that debris, and if there's a risk that you're going to cross the orbit of some of that debris, you can maneuver the spacecraft to a different orbit to avoid that debris. And that is done all the time on the space station. You're going to have similar issues on deep space out with Orion out to the moon, but there haven't been anywhere near as many missions to the moon as there have been in low Earth orbit. So there's a lot more debris to worry about in low Earth orbit. But in low Earth orbit, the Earth's atmosphere does provide some drag and eventually provides a cleaning effect that will clean that up. In deep space, you don't have that cleaning effect. And there's no databases yet for the deep space debris. But that's something we'll have to use all of those techniques to mitigate. And one of the biggest things is to avoid making debris. And that gets into international cooperation to design spacecraft not to generate debris and discard debris in a willy-nilly way.
Okay, another question. Yeah.
Yes, the two kids are asking, how does it feel to So there's two things there for asking. How does it feel to be in space when I'm in craft?
Okay, did you hear the question?
Lots of
Didn't quite hear the question. How does it feel to be something?
Yeah, how does it feel to be in space?
Oh, how does it feel to be in space? It's being in space is an amazing feeling. At first, when you're first launch and are in space, and you get out of your seat and you see little dust particles coming up or your pencil floating over your knee, it seems like a dream. And you come up out of your seat and all of a sudden I felt very unsettled and very tense, like describe it like a cat sliding on the ice. And my claws were definitely out. And it took me a few minutes to sort of get my bearings and to relax. And after a couple of days, you get very, very comfortable feeling in space, and you can just with a touch, you can propel yourself across the room. And you can use all the surfaces of the room. You know, here in 1G, we're definitely walking on the floor, but in zero gravity, you could just as soon be sitting on the ceiling or sitting on a wall as sitting on the floor. So that actually makes the volume seem a little bigger. And when it was time for sleeping, we would we'd have a little light sleeping bag that you'd sit in with your arms floating out of it, and you tie your sleeping bag. Some people would tie it on the ceiling, some people would tie it on the wall, some people would tie it on the floor, and we'd all be in these different positions, hanging from the ceiling like a bat. Some things that I noticed when you're sleeping, your hands are kind of floating like this, and you're in this little sleeping bag. And if you've ever noticed, sometimes when you're falling asleep, you might twitch your arm. And when you're floating in the sleeping bag, if you twitch your arm like that, you recoil and bounce around inside your sleeping bag, and that's very startling.
Okay, another question here. David. Okay, excellent question. Is there artificial intelligence in the Orion capsule?
Could you say the question again, please?
Is there artificial intelligence, AI, on the Orion capsule?
Oh, artificial intelligence. There will be. And the computers that are in Orion are avionics computers, and they have to be super reliable, and they have to work in a high radiation environment, under vibration, under heating conditions. And so that tends to limit their performance, and AI requires a lot of performance. But there also will be laptops on board for less critical functions that you could afford to. It'd be always nice to have the laptops, they're very useful, but if they fail, you can still get home. And those laptops are starting to have the capability to do artificial intelligence. And so there are going to be AI applications available on the crew's laptops. I am confident of that.
Okay,
Yes. So we have a question from Bach. What is the most important lesson you have learned while you were in space?
What was the most important lesson I've learned? The most important lesson is how important teamwork is. Because whatever you're doing, whether it's flying in space or anything else, it really depends on working with other people and having a good relationship with those people so that you trust each other and that you can depend on each other. And that takes a lot of work. You have to look at yourself and think about how you interact with situations, and be very open about those feelings and get past that so that you can work as a very solid team and do great things together. I think that's probably the most important lesson.
I will add a question of mine. How long does it take for astronauts to train to be qualified to fly the Orion?
How long will it take to become qualified to Orion? The current crew has already been assigned, and they are deep in training. In fact, our group has given them about a dozen of their classes, but there are many other groups giving them classes on everything from geology to the food systems and all the other orbital mechanics, which are very complicated for a lunar mission. So their mission is September of 25, and they've already been training for almost a year. Of course, most of those crew members have already flown in space, and so they bring the background of their previous mission that they brought with them, and so they're not going to have 4 beginners fly an Orion mission, but there definitely will be rookies on every Orion mission, and it'll probably be about 2 years of training at least for each of them.
We'll take another question from the chat.
Yes. Yeah. So those are very important questions. Do you believe aliens exist? Do you believe aliens?
Cut out. Sorry, I heard, do you believe, and then it cut out.
Do you believe aliens exist?
Oh, do I believe aliens exist? The odds are that they do, and that's Carl Sagan's argument, that if you look at the number of stars just in our galaxy, and then you realize that there's probably as many galaxies as there are stars in our galaxy, you're starting to get up into big numbers. And if you realize that we're starting to detect with very fine instruments, we've been able to detect planets around many of the stars, it seems likely that there probably would be a planet that would have the right conditions or similar conditions to what Earth had, that could have an orbit that's stable long enough to be able to have life emerge. Now, having life emerge on a planet is different than having a life emerge that is also able to develop a technology and to master interplanetary space and to master all of the things required to actually spread across the galaxy, or much less to span intergalactic space. So I think that it's very likely that there are aliens out there. Whether there is an alien presence where it's a super technology that is able to reach across the vast distances of galaxies or between galaxies to come and reach us, I think that's much less likely. I don't think there is any evidence that would pass the muster of a scrutiny of a scientific peer-reviewed article that has happened, but there are people that have tantalizing evidence that's very, very interesting to talk about.
כן, שאלה מהקהל. איך זה הרגיש לראות את הנוף של כדור הארץ? כן, בחללית. How did it feel to see the view from the window of in space, and especially Earth?
Yeah, how did it feel to see the view of the Earth? That's really really one of the most breathtaking views that you can have. As you look down on the Earth, you can see, actually it's very clear because even though you're 250 miles from the Earth, you're looking through a vacuum, so it's very clear. It's only the last couple miles that have air that diffuse the view. And so it's very clear, and that makes it look like you are closer than you really are, because just because it's so clear. And you look down on the Earth, you can see amazing detail. With your bare eye, you can see contrails of jets. You can see a wave of an ocean liner with a ship behind, a point of a ship with a wake behind it. You can see the highways and the buildings. If you know your geography, you can pick out the landmarks and even find your neighborhood. But you don't have long to look at it because you're moving 5 miles a second, and after a few seconds, you are hundreds of miles further down range, and so you have to look pretty quickly. But you can really see amazing things. It's a spectacular view. If you take a pair of 7 by 50 binoculars, which is a standard type of binocular that we had on the shuttle, and you look down, you can see cars at a traffic light. It's really remarkable, the view that you have, and you can find your house if you really know the geography and you can get there quickly, and assuming the weather's clear. But it is really breathtaking at night. It's really spectacular because you see the lighting of humanity, and so you see the works of humanity very distinct at night. You've probably seen pictures of the Earth at night, but it's very spectacular to remote areas of the world. You see just a few lights, or a reddish light of a bonfire, or a small electrical light. In major cities, you see spectacular lighting that outlines the whole coastline and a whole city, and you can really see the structure of that city out into the suburbs and beyond. It's really a spectacular view.
I'll add a question of my own. We know that on the ISS, the astronauts accumulate the trash, and then the trash gets disposed and burns up in the atmosphere. But around the moon, there is no atmosphere. So what would the astronauts on board the Orion spacecraft would do with their trash?
Yeah, that's a really good question. And in fact, I was just in a meeting this week. We had some discussion of that. It turns out, most of the time, the astronauts are going to be in what's called a near rectilinear halo orbit, which is a large orbit around the moon. It'll take about a week to go around. And it is possible, theoretically, to eject material from that orbit and not have it come back and hit you. But the geometry and the conditions are so critical that the crew could not reliably do that during a spacewalk of throwing it, the way you describe. And so the dealing with the trash is going to be an issue that is, it's going to be dealt with by, one, not creating so much of it, and two, developing technologies so that you can repurpose or recycle or reuse those things that you brought with you. And that's going to just have to be an important part of the technical development of learning to work and live in space long term.
Do we have a question from the chat?
Yes, one last question. So you were selected to be the first man on Mars. You go down the ladder of the spacecraft to the Martian soul. What are your words, the first words of man on Mars? What would they be? Did you hear the question?
No, I didn't hear the question very well. Sorry.
It's a totally hypothetical.
Okay.
Suppose you are the first man on Mars. What would be your first words after coming down from the spacecraft?
Wow, that's quite a challenge. If I had the opportunity to do that, which I will not, given my age, I would have to put a lot of thought into that to say something memorable, because that would be. And there was a lot of discussion and controversy of what was Neil Armstrong going to say, and so you would really have to think hard to top Neil, and you would really want to do that if you're in that position. So I'm going to leave that to that mission commander, whoever that may be, and because that's going to be a challenging task.
All right. I have a question. Are there any similarities, and if so, what are there between the Orion spacecraft to the Apollo Command and Service Module?
Yes, similarities between Orion and Apollo. There are similarities. Apollo had a diameter of about 3.4 meters. Orion has a diameter of 5 meters, so Orion is quite a bit bigger. Apollo had seating for 3 crew members side by side. The Orion has 4 crew members, and 2 are above and 2 are behind them. And so that's a little different. And Orion, was originally scarred, so it could even take as many as 6 people in terms of the layout of the cabin. So Orion is quite a bit bigger in that sense. In terms of the flight instruments, actually, let me talk about the mold line. In terms of the mold line, and we have a capsule here, there's this angle of 30, I think it's 32 degrees, the angle of this cone. And that is the same as Apollo used, and they were able to reuse a lot of the aerodynamic analysis from Apollo by going with that same angular geometry. So that is something that's similar. Apollo used fuel cells for power, which consumed oxygen and hydrogen, so that it had a limited duration. Orion uses solar cells. There's no fuel cells, at least not yet on Orion. So the power comes from batteries and solar cells on Orion. One of the big changes is going to be in the cockpit. The computer capabilities when Apollo was built, some of the first integrated circuits, which were called the RTL family, which you can look that up, RTL, were the first integrated circuits back in the 60s, very primitive by today's standards, but they were very cutting edge. And so some of the first computers were built and were put onto the Apollo spaceship. But all of the instruments were what we today call steam gauges, where you'd have a specific electromechanical instrument that does a specific job. And so the ADI ball, instead of being a virtual picture of a sphere that rotates on the computer screen, that would be that was a physical ball that had a very complicated mechanism of gyros. And so the whole cockpit was different. One thing that's very similar is these switches were kind of inherited from Apollo into the space shuttle. And we use this very similar switches on Orion, but there's a lot less switches, and we have much more use of computers on board.
And the Orion as a whole will be reusable, or?
Yes, the parts of the Orion will be reusable. The avionics that you'd see here, this is not flight avionics, but the avionics, the real ones, are designed to be used 5 times. So after a vehicle lands, the avionics would be taken out of one vehicle, checked to make sure everything's good, and then put into another vehicle several missions later. Mm-hmm. So parts of Orion are reusable, but not the entire spacecraft.
Mm-hmm. Do we have any more questions? Morין, I would like to thank you for your time. This has been extraordinary. I've never seen the Orion. I think we've never seen the Orion in such a close look until now. Thank you very much.
Well, it's been a great honor to be here with you today.
Thank you. Thank you. תודה רבה.
דניאלה?
היי, אתה שומע אותי?
כן, יופי.
היי.
היי.
Hello, we're here. We're just getting settled back in. We'll be with you in just a second.
Okay, great, we're ready.
Okay, are you ready?
Ready?
Hi.
Hello.
Hi, so
Good to
nice to
see
meet
you.
you. Hi, my name is Daniela Ginsburg. I'm from Israel Hayom, which is Israel Today newspaper. Thank you so much for your time.
It's an honor to talk with you.
Thank you. So let me start with a question about your journey from becoming an MD graduate in microbiology, biochemistry, and into becoming an astronaut. Tell us a bit about this.
Yes, well, I went through graduate school in New York and ended up going through the MD PhD program where I worked on DNA repair for my PhD. And for my medical training, I did several years of surgery. And I was up in the Bronx in New York training to be a surgeon. And I decided I didn't want to spend my life in rooms without windows, so I decided to go do something different. So I joined the US Navy and then spent the next 2 years on a submarine.
Wow.
And you know, there I was also trained as a Navy diver in the Navy, and also went into naval aviation and was a naval flight surgeon. I did several tours with the Navy. I ended up actually leaving the Navy, and I was in civilian practice doing occupational medicine, workman's comp, employee clinics, employee health in Florida. But I was a reservist with the Marine Corps as drilling on the weekends types of things. And then when we had the Desert Storm, I was activated as a reservist and came back in and went to the Middle East for the Desert Storm War. And over there, I decided I wanted to just stay in the Navy. So I was already in, so I stayed back in and stayed in the Navy. And I had an opportunity to apply as a military applicant to the astronaut program, which is a very competitive program, as you'd imagine. But I had a pretty wide variety of experiences that made me attractive as a candidate. So I was selected in '96 as part of the Sardine class because it was the largest class ever with 44 people, including 9 international students and 35 Americans. But that was the largest astronaut class ever. So I joined that class, and I got very involved with the technology of spacecraft and was involved with helping develop the space station avionics. And then I was selected for the flight that I was on, which was the STS-110 flight, which was a station assembly flight. And I was selected to do 2 spacewalks as part of that building the space station. So it was really, really exciting. And since that time, I did one tour after my flight in Washington, D.C., where I worked as a Deputy Assistant Secretary of State, working on health, space, and science topics. And did that for a year, and then came back to NASA to lead the team to build prototype the Orion cockpit. And that's where I've been ever since. And we're finally getting this vehicle that you see here. This is one of the training simulators. This is one of the training simulators we use to train the crew and all the flight controllers and so forth. But it's finally coming together, and soon this will be going out around the moon.
Wow, that's insane. one question, is it true that your training as a diver, as a professional Navy soldier, it helped you with your preparations going into space?
Oh, it definitely did. You know, both the aviation training and also the as a diver, you know, trained as a hard hat diver, there's a lot of similarities to that and putting on the big spacesuit and doing an EVA. And a lot of the same considerations in terms of decompression sickness. That's a hazard for people doing spacewalks as well. So those were all valuable things to have in one's background to learn how to do spacewalks. To train for the spacewalks, there's a very large swimming pool here. It's the largest indoor pool in the world, called the NBL, or Neutral Buoyancy Laboratory. You may have seen information on it. And that has full-size mock-ups of the various vehicles for the shuttle, the space station. In fact, at that time, they also had half the pool had the Hubble Space Telescope full-size mock-up, because that crew was training in parallel with our crew for the space station mission. And you put on the suit, the EMU, the big white spacesuit, and you know, move with your hands around the space station. And you have tools like this pistol grip tool that you would use. This is sort of like an electric drill and key tool for doing spacewalks, to be able to tighten connectors and do many other tasks. And so these are all the things that you train in that pool. For each hour in space, you do 10 hours in the pool, and for each hour in the pool, you do 10 to 100 hours of preparation. So there's a lot of background to actually come together in space for a spacewalk.
Wow. And I see a lot of buttons behind you, and I guess that there's a lot of training involved in working on them and working towards operating this spacecraft. So does each and every one of the astronauts on the team supposed to know each and every button, or does they all have different tasks?
So within the astronaut office, there are people assigned to different programs. And right now, there are 4 astronauts assigned to work on Orion. The rest of the astronaut office, many of them would have some initial familiarity lessons, which would just be a couple of hours of training, sort of the big picture, but that's not the detailed training that someone who's going to fly on it gets. So right now we have 4 astronauts who are on the Artemis 2 crew, and they're getting intensive training on that. Within that crew, all of the crew take all of the lessons. Obviously, the front seater and the commander is going to be the one flying the rendezvous task and taking over and flying in an emergency if God forbid that should happen. But all of the crew will be very familiar with all the systems, and they'll certainly know what all the buttons do.
Mm-hmm. So what kind of experiments are they expected to conduct during the flight to the moon?
It's a good question. I know they'll be looking for photography of key things on the moon. And there are also a number of co-manifested payloads, which are smaller payloads that will be going up on that same mission. And there'll be a wide variety of different payloads and micro payloads that will be going up on that mission. Mm-hmm. But the key emphasis of that mission is that it is the first test flight of the mission. So it's really a flight test mission, not a production type mission. And the emphasis will be on checking out the spacecraft systems, seeing what they can do, understanding how they all work in space, identifying any shortcomings or limitations, and making sure that all of the procedures and so forth are, the best they can be for the following crews.
Okay, and so my next question is, if the United States sent men to the moon about 50 years ago, and this technology we would expect would be much less complicated these days. So why is it so complicated to return to the moon, even though we have the technology?
Yeah, the moon is actually, if you start looking at the details of what it takes to get to the moon and what you need to get back, it is really a challenge. And the more you look into it, the more you admire what the Apollo program was able to do with much less complicated computers. The computers in the Apollo day were very tiny compared to the computers we have today, but by cleverly applying them, they were able to do the job and bring all the crews home safely. In terms of the program, we're looking forward of the path of going from the moon to Mars. So this is just a starting point. We don't want to just have a point design that goes to the moon. We want to build up a technical base that enables humanity to stay in space permanently and develop an interplanetary commerce eventually, and an interplanetary culture. Some of the things that we're doing with the Artemis missions, with Artemis 3, where we land on the moon, is we're going to be going to the south pole of the moon. And it's much, much harder to go to a pole of the moon than to go to near the equator of the moon. And it has to do with the orbital mechanics of what it takes to get to the pole. And if you're at the pole, you can't just come back whenever you want. It results in a much more potential delay in terms of days before you can return. So that raises the risks for, if you had an emergency and a leak, you need to be able to come home. And all of those make the technology more challenging. But the advantage of going to the pole of the moon is that the poles have permanently shadowed craters that have accumulated a tremendous amount of water in the form of ice. And those craters there's a crater called Shackleton Crater that is much larger than the US Grand Canyon, which is a very impressive thing. The Grand Canyon would just be lost in the size of this crater. And that has never seen the sun has never shined in that crater for billions of years. But at the bottom of that crater,